Well, thank you, Chief, for this very nice introduction. And thank you all for having me here. It's really a big honor and a great pleasure to be here at the Office of Population Research. So today I'm going to talk about my recent research on using various types of social media data in order to estimate migration. But I'm going to start by saying that, as Chi mentioned in my introduction, I've been very fortunate to be part of three wonderful and complementary centers at the University of Washington: the Center for Studies in Demography and Ecology, which deals with population research; the Center for Statistics and the Social Sciences, which focuses on quantitative methods; and the eScience Institute, which is the data science hub at the University of Washington. So the eScience Institute was started out as a collaboration between computer scientists, oceanographers, and astronomers. Oh, can you hear me now a little bit better?
Pull the torch.
Cool.
Doesn't move much.
Yeah.
What about this one? This one.
Okay, I'll try to speak louder. So I was saying that the eScience Institute started out as a collaboration between computer scientists, oceanographers, and astronomers, and then became more widely, sort of other disciplines became part of the institute. And so by hanging out with people at the eScience Institute, I got to learn that at the University of Washington, there's been a long tradition of oceanographic studies, which is not too surprising given the position of Seattle near the ocean. So this is how oceanography used to be done. People take their boats and they went out to sea and they collected data. They really observed the ocean. So now things are in some ways similar and in some ways different. So oceanographers still go out with their ships and they collect samples, and that's part of what they do. But a lot more oceanographers also spend a lot of time in their labs analyzing data that have been collected using a number of sensors placed at the bottom of the sea. So some of the fundamental questions in oceanography have not changed, but new types of data complemented with traditional data are allowing oceanographers to get new insights into long-standing problems. So this is not something that is specific to oceanography. Pretty much all fields of discovery are transitioning from data poor to data rich, and they're becoming more and more computationally intensive. So if we think, for instance, at astronomy relies on big telescopes that collect terabytes of data every night and transfer those data to data centers. These are sort of big observatories of the sky. If we think of neuroscience relies on data from fMRIs or various types of sensors, and so we can think of those as brain observatories. Similarly, transportation studies is being transformed by a number of data that come from sensors that are placed on roads, on sidewalks, on poles, in public transportation systems, and so on. And so one of the big questions for me is, well, what about demography? And so I see three main trends in this area. The first trend is about the sort of rebirth of old data or traditional data. So these are data that are very useful. They used to be on paper, and so they were very hard to access. They're being digitized, like administrative records, historical records, and they're becoming more usable for research. A second trend is about new data. These are data that did not exist a few decades ago. These are data from social media, from the web, from cell phone data, and so on. And so these are data that were not designed for research purposes. And then there is a third trend that I like to call old new approaches, which is the idea that we're building on traditional principles or old principles in the context of new data. And at the same time, new data are forcing us to rethink some of the approaches and to innovate in that sense in order to fully leverage the new types of data that are becoming available. So new data are particularly relevant in the context of migration. So when we think of international migration, that's the major source of uncertainty for demographic projections, like mid-range demographic projections, say 10 to 25 years in the future. But even if we don't look at the future, even if we consider the present, a lot is not known about the present. So for example, data on age and sex specific migration flows are largely inexistent for a number of countries. And even when they do exist, they're often inconsistent across countries. This is not only in developing countries, but if we think of countries like Italy and Spain, if you want to know the flows from Italy to Spain in 2015, if you ask Spain, they would tell you about 17,000 people. If you ask Italy, they would tell you about 5,000 people. And that's because the data are collected differently. In one case, it's the sending country. In one case, it's the receiving country. There are different incentives to register or deregister, and so on. And so a lot of my work in this area has been about combining various types of new and traditional data in order to get some new perspectives on migration. For instance, I've been using data like geolocated email data or professional histories from LinkedIn or migration histories from Google+, or geolocated Twitter data to evaluate trends. Now, we can think of internet and social media as a discontinuity. So suddenly we have all these new types of data that are available and that could be leveraged for migration studies. Some of these data sources may not last in the future, so some of them might be here for another few years and might disappear. Some new sources may come in. And so it's important to ask what will remain constant in this sort of continuously changing context. And I think there are a few elements that will remain constant. For example, the use and the production of geolocation data will remain constant over time. That is something that is being useful, and it's typically appears across platforms. And so I think that developing methods for geolocated data is valuable moving forward. Also, I think that the interest of advertisers is not likely to change in the near future, and so all the data that are produced with advertisers in mind will stay in the near future. One other element that I think is going to persist in the future is related to the situation of scientists and social scientists. And what I mean by that is that as social scientists, we are in a situation similar to Plato's allegory of the cave. In other words, we are sitting facing the wall. We know that there is some truth behind us, but all we can see are shadows of the truth, that is a distorted representation of the truth. And so we need to develop methods to make sense of these biased representations of the truth in order to understand the underlying population. So in other words, I think that more and more we will have to deal with non-representative samples and how to analyze those types of data. So that was a long introduction, but what I want to talk about with this presentation are two examples of ongoing projects that I'm working on. The first one is about using macro-level data from social media, in particular Facebook data for advertisers, in order to evaluate stocks of migrants. And this is a situation where we have some data and we have ground truth data, and we want to understand biases. And then the second example is about micro-level data. These are geolocated Twitter tweets that we're interested in using to understand relationships between short-term migration rates and longer-term movements. And so in this case, we don't have ground truth data, and so we need to develop other approaches. And finally, I want to situate this line of work within the general or the broader field of digital demography. And if you have any questions, please stop me any time. So I'm going to start with the first project that is about macro social media data and using Facebook data for advertisers. So this is an ongoing project with Ingmar Weber and Krishna Gemmadi. And the first paper was actually published just last week on Population and Development Review. Now, online advertising is booming. So anytime we use any sort of platform, whether it's Twitter, LinkedIn, Facebook, Google, we are shown ads that are targeted to our location, to our interest, to our demographic characteristics, and so on. And so online advertising is basically the main source of revenue for social media data. And so a company like Facebook makes it very easy for people who want to advertise to do so. So say that if you want to create an ad on Facebook, that's very easy. You just need to go to facebook.com/business, you click on create an ad, and then you'll be shown something like this. It's a form where you can choose who you want to target with your ad. So in this example, it may be a little bit small to see, but I chose to target people who live in New York State between the age of 30 and 60, both men and women, who are expats from Italy with a college degree, with college graduates or higher. And so if I do that, then Facebook gives me an answer, and I'm going to zoom in on that. So Facebook tells me that there is a potential reach of 8,900 people. In other words, Facebook estimates that there are 8,900 people who are monthly active users, who match my characteristics, who match the characteristics that I put in, that are Italians living in New York State, and so on. And it does that based mostly on information that users provide on Facebook, like hometown and current country of residence, with the network structure of users, whether they have friends in two different countries, and with the geolocated logins of users, where people log in over time. And so this data comes for free, so we can use it. If at this point, this data is typically used by advertisers to decide on their budget. If they have more money, perhaps they have a broader scope. If they don't have enough resources, maybe they can create a narrower audience. But this tool can also be used for demographic research to get some sense of the demographic characteristics of users, as well as a tool for survey research. Yeah?
You mentioned some of this data is provided by the users and some of it is basically imputed by
Yeah.
Facebook. I agree this is a very exciting approach, but how much do you know about how Facebook is doing that imputation and how stable that process is?
Yeah, so that's a very good question. So Facebook does not provide much information. Like in this specific case, and all of the sort of information that is posted on their website is intended for advertisers, not really for science. But people internally at Facebook also publish some work. And so what we could do was to look at this data and some of the tables that people publish from internally at Facebook, and we check that the sort of hierarchies match, and we sort of assume that the methods that they describe in their published work is consistent with these methods. But it's true that we don't really know if Facebook tonight decides to change the algorithms, then it would be very hard for us to know that.
Could you at least check the internal consistency? So if you say the number of Italians who have gone to college in New York should be less than the number of Italians in New York, or something like that, where you could, there are certain relationships that have to be true.
Yeah. Yeah. So you can check something related to internal consistency. And so for instance, if what we did was to create queries for smaller areas and then aggregate up and see whether like they make sense. And usually they make sense. Like they don't exactly match because there are all sorts of rounding. So for instance, if you see a number that is 20, that means 0. So a value of 20 in this context is 20 or less. And so if there's nobody that matches your criteria, you never get a 0, you still get a 20. So there are a few sort of rounding issues like that. But yeah, the idea is to sort of check for these consistencies or inconsistencies. Okay, so we could look at this data, and if we had to do it manually, it would be a little bit tedious, but luckily Facebook has an API, a marketing API that is fairly well documented, and so we could actually extract the data fairly quickly. And so we got some data, and then we decided to compare that data with the American Community Survey. So here is an example related to migration. So in this chart, each data point represents a country of origin and the US state of destination. So for instance, these are Mexicans in New Mexico with a value on the y-axis from the American Community Survey, the fraction of foreign-born according to the American Community Survey, and on the x-axis is the fraction of expats according to Facebook. This dashed red line is a 45-degree line, and the blue data are the same data in this plot, just on a log-log scale. And so this chart showed us that there is some signal there. There may be a lot of noise, but there's also some signal. If we look at the log-log plot, there's a fairly linear relationship. We could also say that, well, Facebook tends to underestimate migrants. Most of the data points tend to lay above the 45-degree line, but it gives us a sense that potentially there is some information there that could be extracted. We also looked at something similar in the context of various countries in the world. So for this plot, each data point is one country in the world, and the values represent the fraction of migrants from all other countries in the world. And we compare the data from the World Bank against the data from Facebook. And this line is a simple regression line. So what we see here is that the relationship is not as strong as for the US. We might expect that different countries might be biased in different ways, but there's still a fairly strong relationship, together with some clusters. So we can see that all African countries tend to be clustered below the regression line. European countries tend to be clustered above. So it gives us a sense that there is potentially something, but there are also a number of biases that are hidden there. Yeah.
So I think these are surprisingly good. This is better than I expected it, especially because the so-called ground truth is measured there also, right? Like there's sampling uncertainty and ACS estimates of small groups.
Yeah.
So how do you think about quantifying the uncertainty? I mean, so we know how to quantify the uncertainty in the ACS. How do you think about quantifying the uncertainty in this other source of data?
So that's a good question. And the tricky part, I would say, is that when I think of uncertainty, I usually tend to think first at sampling uncertainty. But in this case, most of the uncertainty is not necessarily related to sampling.
Yeah.
It's more related to bias and all sorts of biases. So the proportion of uncertainty that is related to bias is much bigger than the proportion of uncertainty related to sampling. And well, maybe like, I'll talk a little bit about the bias and we'll see if that sort of like addresses a little bit your question. We can talk a little bit further about that, which is a very important question. But it's also, so just to give you a sense, Facebook also gives a lot of information about other things like interest. So for instance, it would tell you how many people, like it would give you estimates of people who have young kids, for example. because that's interesting for advertisers. They want to advertise it when you have a young kid or like when you have a newborn. And so for things like that, it's much hard. So the estimates, we took a look at those as well, and the estimates do not line up as well, because I think it's much harder to estimate whether you had a child or not than whether you sort of like, you are from Italy and you live in the US. So I think like things with location are fairly easy to estimate. Things related to interest are a bit harder.
Can you do
Yeah.
this on active Facebook accounts?
Yep.
Because people deactivate, but I understand they don't ever go away. But they still have your account, even though it may not be open to the public. So can you access those that have been deactivated as well as, or only those that are currently active?
Yeah, well,
Do a scoop.
I'm not sure, I didn't read about that, but like my guess is that since this is for advertisers, they're interested in active users.
Okay.
So that's what I would say. And it's actually, well, it actually, yes, sorry, so the measurement is actually for monthly active users, so non-active users are not there. So we looked at profile, so we thought like perhaps there are biases that are related to different age groups, and so we looked at profiles by age and sex. So here is an illustrative example with Mexicans, men and women in California and Texas. So this is an extreme example. Like we have the ACS, that's the red line, and then the dashed line is Facebook data for the fraction of people in the state. And so we see that even though like at an aggregate level things look fairly consistent, when we start disaggregating things, we see bigger biases. For young age groups, the two data sources line up fairly well, but for older age groups, we see that there is a big bias between sort of Facebook and the ACS. And this could be related to all sorts of things. It could be that older people do not use Facebook, or older people use Facebook, but they don't put much information, or older people put as much information in terms of like hometown and current city, but they don't spend enough time on Facebook to reveal other information about where they are. So there could be all sorts of biases. But what we think is interesting in this case is that the biases tend to be sort of consistent across states. And so if we can model those biases, we can sort of borrow strength across states and understand some of these biases in order to make corrections. So this is just an illustrative example to get a sort of more systematic assessment of these biases. We ran a simple regression model. Where on the left-hand side, we have the foreign-born population from country I to US state J by age group Z. We had the respective value from Facebook. And then we had a set of dummy variables for countries of origin and for age groups. So these dummy variables are intended to serve as some sort of level parameter. Each country has its own level, and some sort of shape parameter. Different age groups have different biases attached to them. And so we got a table. There are a lot of numbers here. I think the interesting ones are the age groups, and so I'm going to zoom on those. So we see that the coefficients tend to be negative for young age groups, meaning that on average, Facebook tends to overestimate migrants for younger age groups and tends to underestimate migrants for older age groups, which is not surprising, is similar to what we saw in the example. Yeah.
I understand how Facebook could underestimate migrants, but in what way would there be an overestimate? Would it be that like migrants are more likely to be active than native born among those ages, or what would be?
I think that could be the case. It could be that migrants, if migrants use Facebook more than the average person of the same age in the US, or if a migrant puts more information, if a migrant puts more information on their profile than the average population, there could be a reason, I would say. Okay, so once we sort of got those values, then we thought, well, can we perhaps predict the total number of foreign-born from country I in state J? Say, if we want to know how many Mexicans live in California or how many Italians live in New York, can we say something about that? So what we did was that we divided the data into a training set with 80% of the US states of destination and a test set with the remaining 20%. And then we estimated a sort of naive model where we do not account for biases related to age and country of origin, and a model where we disaggregate by age and country of origin. And so what we got was that the mean absolute percentage error on a number of test trainings or test sets tend to be quite high when we do not disaggregate by age and sex. When we do not account for those differences, we get 56%, and it goes down quite a bit when we account for these differences by age and sex. And so the idea here is that if we can account for various biases in different subgroups of the population, and it's something that, like, the idea is in a way similar to sort of post-stratification, that might help us make predictions. And then there are trade-offs, like ideally we would sort of slice up things in smaller groups, but then like we cannot slice it up too much, otherwise we would have lots of empty cells. And so there are trade-offs there. Now, so at this point, so this is like the next steps in this project are about combining additional data from DSCS. So far, we've been looking only at sort of one snapshot of the population according to Facebook and one snapshot from the American Community Survey. But the American Community Survey has been around for a while, so we have time series, and we can also combine that information. For instance, when we look at Facebook data only, we do not have any constraints on age patterns. But as demographers, we know that there are some regularities in age patterns that we want to sort of account for. And so the idea is that we can use a model based on principal component analysis, something similar to a Lee-Carter model, but instead of using mortality rates, we use migration to sort of add some constraints on age patterns. So for example, if we look at if we look at profiles by age for the American Community Survey, these are Mexicans in California, we see that there are sort of like some predictable changes over time, changes in level, changes in shape, and so on. And so we can leverage that. If when we tested this simple model, a sort of simple Lee-Carter model with migration, this is an example of results. So the American Community Survey data for 2015 is the red line. We use data up until 2014 from the American Community Survey to make a prediction for 2015. And we have a prediction from the American Community Survey data only. And so the general idea here is that we have two different types of models, and perhaps we can have more models. We can combine predictions for these two different models, given that sort of they're not completely orthogonal, but like they may sort of pick up different things. The time series model may sort of like give us a sense of extrapolation of like ongoing trends, long-term trends. Facebook data might be useful to incorporate sort of recent shocks. If something happens that was unexpected, we may be able to pick that up from Facebook, not so much from the American Community Survey because the latest data point might be 2 years old. And then we could combine that as a weighted average of the two models based on the past performance of the two models. So this is something we're working on, and so I don't really have additional results to show you on. I hope to be able to show you some results next time I see you, but I wanted to give you a sense of where, like, the direction of this project. Yeah.
I think it's really interesting to bring in the time series. I thought you were going to bring in time series data from Facebook. Because one of the concerns you had expressed is about instability of this data source.
Yeah.
And so how would you think about trying to handle that with time series?
Yeah, so that's a very good point. We've been collecting data for Facebook for about a year now. So like every month we collect the data, but that's how long our time series is. And so in this context where we're interested in long-term trends, that is not super useful. But for short term, that could be useful. If we have like stocks at different points in time, what we want to see is whether we can predict short-term flows based on these repetitions of stocks. So if things are changed from month to month, maybe we can say something, but we cannot collect data for the past from these APIs. So that's the tricky part.
But even for this 1 year, have you seen like very unusual fluctuations?
We didn't notice very unusual fluctuations, but like what we see is that every time we collect the data, there are more users and more migrants. It's like the things are like going up, and so perhaps some of those changes need to be filtered out, but we didn't see big fluctuations. But it's a good idea that sort of looking at the fluctuations might give us a sense of the variability in this data and at the extent to which we should rely on those. And this is like, yeah, the uncertainty as well. Yeah.
I'm thinking I missed something. What's the definition of migrants in this study? So if someone migrates to that, how long he or she has to stay in that place and become as a migrant?
So that's a very good question. And so for this type of data, there are definitely a number of issues related to measurement. Like, it's not completely clear what these, like, the sort of measurement issues. What Facebook says is that those are people who come from one country, who previously resided in one country and now reside in this second country. This sort of like, but we don't really know for how long they've been there or all these kind of things. So the definition is not super clear. And what we're trying to do is to sort of like reverse engineer this and say like, if we can backtrack the definition in a way. Okay, so that was like, I wanted to show you an example with macro data. Now I want to show you an example with micro data. And this is about using geolocated Twitter tweets to study sort of relationship between short-term mobility and longer-term movements. And it's a joint project together with Di Fiorio and a number of other colleagues. So for this case, we have individual level data, Twitter tweets with geographic coordinates attached when people posted on Twitter. This is something that is part of a sort of panel data that we're trying to create. We started with a previous work that we wrote several years ago, where we collected some Twitter tweets with geolocation, and since then we've been following these people. Every so often we update our sample. So we have a sample of about 60,000 users that initially, in the initial data collection, posted at least 8 geotagged tweets in the US between 2010 and 2013. And so we've been collecting those tweets over time.
Can you explain what a geotag tweet is?
Yes.
So if I'm here
Yeah.
and I tweet, and then I go to California and I tweet, would that be 2 tweets, 2 geocodes, or the same person? Is
So-
it a person or place-based code?
So you need to have geolocation enabled, and so if you don't have it, probably
No.
probably there's no geolocation attached to it. But if you do have geolocation enabled, every tweet has the geographic coordinates attached to it. So if you tweet from here now, you would have like the geographic coordinates of where you are right now, and the next tweet would have the geographic coordinates of where you are at that point.
But it would be still person-specific.
Yeah, so
So you know that I moved and gave tweets from 2 places.
yeah, so each user has a unique ID, and each tweet has a unique ID, and the geographic coordinates are attached to each single tweet. Yeah.
Do most people actually open up the deal?
No, it's a small percentage of people. It's something like maybe 3%, 5%, something like that. So it's a small proportion of the.
Is that the default option?
No, it's not the default.
You actually have to enable it then?
Yeah. And there are different types of geolocation that you can enable.
Yeah,
Some,
I'm not a tweeter, so there are other people that tweet their life out, but.
yeah, so you can decide on this sort of like level of coarseness. So we took those geographic coordinates and then we mapped them to the 9 census divisions. And so in this case, we're interested in flows rather than stocks. Yeah.
Another Twitter-related question about bots. Like,
Yeah.
how do you do bot detection?
So,
Oh, bot. Sorry. Bot.
Sorry, I didn't hear what you
So
said.
sorry. Yeah. So
Bot.
in Twitter, not all the tweets are from people. Some of them are from bots that are doing all kinds of things. The bots could move. I mean, because the reason why, because geolocation is unusual, then that seems like the kind of thing bots might do. They sometimes do unusual things. So that's.
yeah, so that's a good question. And there's no guarantee that we remove the bots. There could be some bots in there. Like our criteria was to sort of, when we started this and was several years ago, we decided to choose some users who had been on Twitter for a long time. So we thought that like if those people had been, so if like several years ago, we looked at people who had been on Twitter for a long time, we sort of thought like those must be trusted users, like before like more and more bots sort of like jumped in. And so the idea is that by following those users, little by little we might lose some because they may stop tweeting or they may stop tweeting with geolocation, but they should be relatively safer than the general population. But there could be, and we wouldn't know.
But you have it, so you could look.
You mean we can look at? We could potentially sort of pass it to some. So there are people who have worked on identifying bots, so we could probably pass our ideas to those, and sort of like we will get an answer about the likelihood that there are bots. But then like I gave my idea and I was identified as a bot, so I don't know. Those tools are not necessarily perfect as well. And so we consider these census divisions and the flows between them. And so the idea for this work is to evaluate whether rates of mobility or rates of migration change as we change the definition. So like the overall goal behind this is that perhaps we can say something about that. Maybe we can use some of these tools for harmonization of data. And we're thinking about European countries where different countries have all sorts of different definitions. And we try to start with the US where we consider different divisions as sort of like different macro countries. And so there are two key concepts that we consider. One is we're this time series of geographic coordinates for each user. And then there are two concepts that we consider. The duration, which is the sort of like the buffer around one period of time that we use in order to infer the residence of the person. And the interval, which is the period between two time points in order to establish whether there was migration between the two time points. So just to clarify that, this is a sort of illustrative example of data for two users. So the two panels have the same type of data, user 1 and user 2. user 1 and user 2 tweet from location blue and location red. We want to know the residence of user 1 at time t. In this case, we have a short duration, a short buffer around time t, and we pick the modal location from where user 1 tweets as the residence. And so in this case, for the top panel, with short duration, we would say red and red. Whereas for the lower panel, if we increase the duration, then we would pick blue and blue. So if we have a short duration, like in my case, for instance, with a short duration, I will be a resident of Prisnon if I have like 2 days of duration. But if I have a 2-week span, I have enough time to go back to Seattle and post most of my tweets from Seattle. So we looked at how the migration rate, the mobility rate, changes as we sort of change duration. And so as duration increases, as this buffer increases, migration rates tend to decrease. Then we also consider interval. So in this case, we keep the duration constant across the 2 panels, but we change the interval. So the distance between t and t++. And so we looked at how migration rates change as we change interval. And so as interval goes up, then migration rates tend to go up. So we may be more likely to be in the same place 1 month, like next month, but perhaps in 10 years, we are more likely to be somewhere else. And so we put all of these together to get a sense of how migration rates change with respect to a combination of interval and duration. And so these types of data we think that are potentially useful because we have these migration histories that we can sort of keep track of. And we wouldn't be able to sort of look at differences in terms of migration rates for the same people when we change interval and duration without this type of data. The flip side of it is that we don't really have ground truth data or like some sort of census data that we can compare this data with to see whether they make sense. And so far, our approach has been to look into as many geolocated sources as we can to see whether some patterns are regular across different platforms. So we've been looking into cell phone data for Senegal, an old social media that doesn't exist anymore, GoWalla, where people could log in, and potentially we will look into administrative data from Sweden. And so as an example, we see that, so these are relationships between migration rate and interval for data from Senegal. So these are called data records for Senegal, the Twitter data that we saw earlier, and the GoWalla. And so there are differences there, like this is something that we're working on right now, but the general idea is that we want to evaluate whether some of these patterns are consistent across situations. If something is consistent for Twitter users in the US, Senegal phone users in Senegal, and GoWalla, people who check in and so on, then we might sort of be comfortable with the idea that those are fairly regular patterns. If there are discrepancies, then we may want to sort of look into why there are discrepancies and try to understand what's explaining those. Yeah.
Do you make any distinction between short distance migration, so like from Connecticut to California versus short, like Connecticut to New York? And are you able to tell the difference between migration versus just commuting behavior?
Yeah, so that's a very good question. Like we haven't really put too much sort of like space constraints into this. So the reason why we don't really look into sort of like short distance versus long distance is mainly because the sample in the end is not that big, and so that's why we sort of like aggregate things at the level of census divisions. And so people who sort of cross the border are counted the same as, so people who live near the border are potentially counted the same as people who are not at the border. And so that's So that's something that we should definitely take into account. We haven't done it mainly because of the constraints of the sample. But yeah, it's a very good question. Okay, so this is an example of that line of work. And so now I would like to sort of say something about how this work sort of fits in within digital demography. Now, with a number of people, I'm part of this panel, this IUSSP panel on big data and population processes, which includes a number of traditional demographers as well as computer scientists or people who work at Facebook, for example. People who work in the industry. And so as part of this panel, what we've been trying to do is to sort of form a community or help form a community with a shared set of tools and set of approaches. For instance, we've been running some training workshops that are specific. So workshops in computation methods at population conferences or workshops in demographic methods at computer science conferences. And then at some venues like the International Conference on Web and Social Media, we use that for research workshops that bring together people from different disciplines. And some other activities like a special issue of a journal like Demographic Research. So there are lots of examples of research in this this context of digital demography, and I just want to give you, just mention a few examples that include the use of geolocated tweets with modern statistical approaches to estimate population density, for example, or the use of Google searches and Google Trends with econometric approaches to nowcast fertility, or the combination of Twitter data plus text analysis and a natural experiment in order to evaluate the impact of laws like the SB 1070 that restricted immigration on attitudes towards migrants. Other examples include the combination of Google search activities to evaluate differences in the relationship between Google search activities for ultrasound and sex ratios at birth across Indian states. Or the use of Facebook data and network analysis to map communities of migrants. And approaches related to survey methods, such as using Facebook Ads Manager, the same tool that I described, to survey hard-to-reach populations, like Polish migrants in Austria. So I stopped before they ask for your credit card and you can set an ad, but you can also go ahead and create an ad and ask people to participate in a survey. And so these are just a few examples of this type of research that is done that is at the intersection of computational social science, digital research, and demography. And so I sort of pointed out to those examples because I wanted to say that the digital revolution is really changing how we do demography, but not necessarily the reasons behind it. For instance, a lot of the examples that they showed address the same fundamental questions that we are interested in demography. We want to understand, so for example, we may be interested in attitudes towards migrants, but we may consider not only surveys, but also what people post online, and that might give us some different measurements of the same type of phenomenon. Or in the past, we recruited survey participants only with landline phone numbers. Now we can also do it with Facebook data. And so at the same time, this data also allow us to address a number of new questions that previously we couldn't. And so in particular, I think the geolocated data, together with migration histories for a large number of countries, may potentially help us sort of discover some regularities in mobility patterns and relationships between, say, internal migration and international migration, or short-term mobility and long-term migration. So I think that in this area, the road is exciting and difficult. That's what makes it rewarding. And I think that developing methods is really key in this area. Eventually, all these data, all these digital traces will become just any standard data. We will know what they're useful for and what they're not useful for. And there will become some common knowledge, like the same way we interpret live tables now. We know the assumptions behind them. We know when they're useful, why they're useful, and so on.